I want to talk about, put your phone away for the remainder of class. Thank you. Yes, that's on YouTube. I didn't say your name, but I will next time. I want to talk about what's called dimensional analysis or unit conversion. This is actually a really, really useful skill. This is how you can change units from one thing to another thing. Sarah Ashley, this is not the easiest method, the one that Mr. Perugia and I are teaching you. It's the best method, though, because it works for everything. Now, let me emphasize, if you have other tricks or methods that work for you, and you're always getting the right answer, do it your way, and I'm fine with that. I won't make you do it my way if you're always getting the right answer. But if you're always getting the wrong answer, maybe you want to try it my way. Again, this is not the easiest method, but it is by far the best method. In fact, if you're clever, this is very, very flexible. I was writing a second-year calculus test, and the question said something like this. There's a classic calculus problem. It says you have a pool that has 1 million liters of water in it, but the water is 20% salt solution. You're draining the pool at 5 liters per minute, and you're pouring in 2 liters per minute of a 50% salt solution. After 1 hour, what percent of the pool is salty? That's a really complicated question. You can do it with calculus in about 2 lines. And I remember I was writing the test and I blanked. I couldn't remember the calculus method. I was able to set up like a 15-term unit conversion dimensional analysis chain, and I got the right answer. My prof wrote a little note, you know, there's a shorter way to do this. And I was, yeah, I just forgot. So what are we going to do? Today we're going to teach you how to multiply by 1. Funny looking ones, but ones. Read along with me. It says this. If A times B equals A, what must B equal? In other words, if 5 times blank equals 5, what number must be sitting where the blank is? Got to be 1. Okay? So the first thing we're going to put in our back pocket is we're going to realize that if we multiply by 1, we get the same answer we started with. That's very profound. It might look different, but as long as you've multiplied by 1, it must be the same answer. Second thing we're going to say, Bryce, is I can write 1 in many different ways. For example, 7 over 7, is that 1? Yes. What about this? 2 times 10 over 5 times 4. Is that 1? Yes, because the top and the bottom are worth the same thing. Ooh, what about this? 7 days over 1 week. Is that 1? Yes, it is, because the top and the bottom are the same thing. They look different, but they both have the same value. It's that third one, something like this, that we're going to take advantage of. We call these conversion factors. And with a bit of cleverness, you can dramatically drop down your memorization. I forgot to say, you're going to want the back page of your green sheet out. Absolutely. So open your green sheet to the back page, the metric chart. The chart with all the metric prefixes, unless you've memorized them all.
Yes, of course.
Okay. Hey, is 4 quarters over 1 loonie, is that equal to 1? Yes. The same thing. It's, again, funny looking one, but it's a 1. So, any fraction equals 1 as long as the numerator, the top, and the denominator, the bottom, have the same value. We can use this for something called dimensional analysis or unit conversion. We can use this to not have to memorize a bunch of crap. Instead, we can just derive what needs to be done. We're going to multiply by a series of conversion factors, Declan, a series of ones, until we get the units that we are looking for. Since we're multiplying by 1, our answer won't change. It must be the same as what we started. We're just going to make it look different. We're going to change the units. And we call these strange looking ones, I already used the term, conversion factors. Let me give you an example. Now, you might already have a method for doing example A and B, and if you can do it, and if you can get the right answer, always with confidence, then Ella, I'm fine with that. But I'd like to show you one method that works all the time, and I like it because it lets me start with a bit of a no-brainer. It says, given that 1 kilogram equals 2.2 pounds, convert 12 pounds to kilograms. Anytime they ask me to convert something, first of all, as a teacher, I will always try, if I can, to give you kind of a no-brainer, something that you can write down so that the question is no longer blank and you feel better. It gets the juices flowing mentally. For unit conversion questions, Casey, I always start out by just writing down what they gave me. What did they give me in A? 12. And I told you yesterday that my abbrev for pounds is the pound sign on your phone. You can write out pounds or LBS if you want to, but that's shorter. I always start out by writing down what they gave me. Why? Is the question blank anymore? No. Am I more relaxed? Yeah. Do I feel better? Yeah. Oh, and also, I'm going to do one more thing just this once, and then I'm never going to do it again, Sadie. I'm going to let you realize that that's technically a fraction. Anything is a fraction. They're always over 1. Alex, I'm not going to write the over 1 again, but can we just use our Sesame Street imagination and realize that it always... Okay. They want me to convert this to kilograms. To do that, I'm going to multiply by a conversion factor. I want pounds to cancel, to vanish. Alex, where is pounds in my original term? On the top or the bottom of the fraction? For it to cancel, where is it going to go in the next fraction? On the... Yes, I'm going to put pounds down there. You know what goes on the top then? I guess kilograms. Except now I need to put in the numbers. Apparently 1 kilogram is 2.2 pounds. I have to fill in the conversion factor. That 2.2, is it on the top or on the bottom? So am I going to go 12 times 2.2 or 12 divided by 2.2? How do I know? Because it's on the... This takes care of the question of, do I multiply or do I divide? It answers it for you. In fact, if you look close, pounds would cancel, and can you see the only units left behind are kilograms? By the way, technically on your calculator, you would go 12 times 1 divided by 1 divided by 2.2. Will the timesing by 1 and dividing by 1 make a difference at all? We're going to skip those. So on your calculator, 12 divided by 2.2. What do you get? Oh, let's ignore sig figs for this lesson. Let's go to, I don't know, 3 sig figs when in doubt. So 12 divided by 2.2. 12 kilograms is 5.4545. I'll just write 5.45. Sorry, 12 pounds is 5.45 kilograms. This is the dimensional analysis method, and it's a little weird at first, but I'm telling you, if you wrap your brain around it, Sarah, hugely useful tool to have in your back pocket of nerdishness. Sarah, can you read B to me out loud, please? Convert. I'm going to write down what they gave me. 64 kilograms. I've written something down. I feel better. I'm going to realize that it's over 1. I'm not going to write the over 1 because I'm naturally lazy. I'm going to multiply by a conversion fraction. Sarah, I want to cancel out kilograms, so where is it going to go in my fraction? On the... Yes. What if kilograms was on the bottom in the original? Where would it go in the next fraction? On the... Yes. So you just want to set them up like that. So I guess on the top is going to be pounds, and my conversion factor says 2.2 pounds is 1 kilogram. Sarah, where is that 2.2, on the top or on the bottom? Am I going to multiply by 2.2 or divide? This answers the question for you. And you can always do a built-in check. If you cancel out units, you should end up with the unit that you want sitting where you want it. 64 times 2.2. I can do this in my head. 64 times 2 is going to be 128. It's going to be 128 plus 12.8. It's going to be 128. It's going to be 130. It's going to be 140.8. 4 sig figs in my head. I can do math in my head. Units. pounds. This also works with your metric prefix system. So if we're using the metric prefixes, do you need to memorize the metric prefixes? No, they're on your green sheet. I call these one-step questions because we're either getting rid of a prefix or bringing in a prefix. So convert 12, what's capital M and abbrev for? Megagrams to grams. Anybody want to guess what I'm going to do first? Write down what they gave me. 12 megagrams. Sadie, have I written something down? Do I feel better? Am I more relaxed? Are my odds of success? Yes. I'm going to multiply by a conversion factor. I want megagrams to cancel because there's no mega here. So where's it going to go in my next factor? On the? Yes. What do I want left behind on the top? Just plain old grams, except this is not a 1. This is illegal. We're not done yet. Now what I need to do, Diego, can you find mega? Tell me the 10 to the that mega is. It's on your sheet somewhere there. He's looking, he's looking, he's looking. 10 to the? No, that's milli. Capital M. Capital M. By the way, I'm glad you made that silly mistake. Don't do that. Yes, you gotta pay attention. What is capital M? 10 to the, it's positive 6, is it not? Okay, where does the 10 to the 6th go? Where the mega isn't. Here. What we're really saying is 10 to the 6 grams is the same as a megagram. So Diego, where is that 10 to the 6th? On the top or on the bottom? Am I going to multiply by 10 to the 6th or divide by 10 to the 6th? How do you know? Because it's on the, I'm looking at a word that starts with the letter T and rhymes with pop. So get your calculator out. This isn't scientific notation, so I'm not going to use my scientific notation button. I'm going to go 12 times 10, exponent button, 6. I get a 12 and 6 zeros, and if you write that, that's fine. I think it's going to be less work to write this in scientific notation, so I'm going to write this in scientific notation. It's going to be 1.2 times 10 to the, I don't think 6. 7 grams. 12 megagrams is 1.2 times 10 to the 7th grams. Number 2, 13.6 amps, and I want to convert that to milliamps. Anybody want to guess what I'm going to do first? Write down what they gave me. Declan, I want to get rid of amps. Where's it going to go in my next fraction? On the? Yes. What do I want on the top? I want milliamps, except I'm not done yet. I haven't yet replaced the metric thing with the 10 to the. Milli, 10 to the what from your green sheet, my friend? Where is it going to go? Where the milli isn't, which in this case, unlike here on the top, here it's going to go on the bottom. So if it's on the bottom, Declan, am I going to times by 10 to the negative 3 or divide by 10 to the negative 3? Yep. So on your calculators, you're going to go 13.6 divided by 10 to the negative 3. And by the way, this is why I didn't like your answer sheet that you guys were working on, because they were changing this into a multiplication question. And you can get there by multiplying, but you're actually then getting rid of a negative exponent. You're doing two things at once. I would rather have one method that just works and I can do the same thing mechanically. 13,600, yes? Is it less writing to write that out, or is it less writing to write that in scientific notation? I think it's less writing just to write that out. So I'm going to write it out. 13,600 milliamps. And again, you'll notice, Finley, amps cancel, milliamps, it's all that's left behind. I call these one-step questions because you can get to the answer in, wait for it, one step. I call these two-step questions because I'm starting with kilo and I'm ending up with, ooh, what's that funky symbol? That was the Greek letter mu, micro. So here's my strategy. I'm going to start with kilo. I'm going to get rid of it. Then I'm going to bring in micro. That's why it's two steps. Okay, so you want to guess how I'm going to start out? Write down what they... Yep, 13.6 kilograms. I want to get rid of kilograms. Where is it going to go? How do you know? Because right now it's on the... Yep. And I'm going to have just plain old grams. Step one is just getting rid of kilo. Except this isn't quite right. Kilo, KC, is 10 to the what? Where's the 10 to the 3 going to go? Don't memorize top or bottom. Memorize it goes where the little k isn't, which in this case is on the top. If I stopped here, that would be grams. But I want to end up in micrograms. So, second fraction chain. Now I want to get rid of grams. Where is it going to go? On the... Yep. And I'm going to bring in micrograms because that's what I want to have on the top because that's what the question told me. Except, again, I'm not done. I need to bring in the power of 10. KC micro is 10 to the... Is it negative 6, I think? Where is that going to go? Where the micro isn't. Yep. I'll times by 10 to the positive 3. I'll divide by 10 to the negative 6. I have no idea what the answer is. That's what my calculator is for. 13.6 times 10 to the 3 divided by 10 to the negative 6. And I get, ooh, my calculator gave me an answer in scientific notation, so I'll go with it. I get 1.36 times 10 to the 10th micrograms. There are all sorts of shortcutty ways that you can do the metric system. And if you know how to do them, Riley, and you can get the right answer, let me emphasize again, do it your way. And as long as you're always getting it right, I don't care. If you're consistently getting it wrong, maybe you want to cave and come over to my method. Not the quickest method, not the easiest method, but it always works. Ooh, 2,000. Ooh, Sadie B, what's lowercase n? Is that nano? Sadie B. Oh, now there's only one Sadie, so Sadie. Is lowercase n nano, I think? Yes? Okay, going to write down what they gave me. By the way, whenever you're writing liters, if you're using a lowercase l, always write it in cursive. Why wouldn't you write a lowercase l like that in a math class or a physics class? Looks like a 1. So you're always going to see, I'll write an L in cursive. Also, that's a Z. That's a 2. So just so if you're trying to read my writing, I will be pretty consistent on that. And I'll almost always put the little line through the 7. So in the back corner, you can tell that's not a 1. Also because in Europe, that's a 1. Didn't know that? Yeah. So I'll try and be careful and meticulous in my writing, okay? Ooh, Sadie, I want to get rid of nanoliters. It's on the top, so where's it going to go in my next fraction? On the... Yep. Just like you dropped... Yes, down there. There you go. You were miming it. I like that. And I'm going to have just plain old liters left behind, first of all. I'm getting rid of the nano. Sadie, nano, 10 to the negative... Is it negative 9? I think. Yeah, I remember nano 9. I remember nano negative 9. The ends there. Where's it going to go? Where the nano is not, which in this case is on the top. If I stopped here, that would be liters, if it was a one-step question. But I don't want to stop in liters. Sadie, I want to end up in mega liters. So I'm going to do another conversion factor. I want to get rid of liters. Where is it going to go in my next one? On the... because it's on the top here. And I'm going to introduce megaliters because that's what I want to have left on the top, except mega 10 to the what? I think 6, but double, yes? Okay. I usually end up memorizing these every unit while I teach them, and then I forget by the end of the year. Where is the 10 to the 6 going to go? Where the mega is not, which in this case is on the bottom. So on our calculators, it's going to be 2,000 times 10 to the negative 9 divided by 10 to the 6th. And I got a typo. Come on, Mr. Duick. 2,000 divided by 10 to the 6th. You get 2 times 10 to the negative 12? Megaliters. I should say, I like this question, I like this question, I like this question, I like this question. Why would I say that? Why would a teacher say something so bizarre? It's going to be on the... Did you hear me say it's going to be on the test? Or you noticed when your teacher emphasizes certain things, you're the kind of student that picks up on hints when teachers emphasize things? Well, good. There's definitely going to be a 2-step question. In fact, it's probably going to be two-step questions on the quest. Okay? Try number 5 on your own. I'll do it up here. Let's see if we end up in the same spot. You can use your method if you're always getting it right. Otherwise, do it my way. If you're finding this tricky, by the way, you're normal. This is a tough concept. But if you wrap your brain around this, you're set. And also, this is how Mr. Perugia is teaching it in chemistry, or if you take chemistry next year as grade 12s. I got 3.425 times 10 to the 8th. Actually, I got on my calculator 3425 and then 5 zeros. And I thought it's less work to write that in scientific notation, so I wrote it in scientific notation. How many of you got that okay? Good, we're getting there. Units matter. I am going to be fussy on any quiz, on any test. Your final answer must have correct units. If you have the wrong units or you have missing units, I will take off marks. So a good habit before you hand in any quiz or any test, check the written section and make sure you've got units on all your final answers. Put your pencils down and look up. So, little hashtag nerd trivia for you here. Did you hear? Yeah. You got it okay? Yeah? You able to write it down all right? Yeah, you got it? Earthquake? Okay. Part C. The reason I like this unit conversion method is it lets you tie into stuff that you've already memorized without having to memorize extra garbage. Here's what I mean. Example 6 says, how many seconds in 1 week? First of all, does anybody know how many seconds are in 1 week? Because if you do, you can just write down the answer and you're good to go. I don't. I've never bothered memorizing it. You know what I'm going to do? I'm going to write down what they gave me. 1 week. What can I convert weeks into? And this is something all of you know. You've memorized it just because you're growing up. What can you break a week into? How many days are in 1 week? All of you know this. So, where am I going to put weeks in my conversion factor? On the weeks right there, days right there, 7 days, 1 week. Oh, or Sarah, you could have put 14 days and 2 weeks, because that's a 1 still. You could have put 21 days and 3 weeks, but usually we use the simplest convert. You could have put 3.5 days and 0.5 weeks. Those all work. Usually we go with the simplest one. If I stopped here, I'd be in days. Does anybody know how many seconds are in 1 day? No? What can I break days into? And you've all memorized this just because you've grown up. How many hours are in a day? You all know this. So let's use that. Let's go. I want days to cancel on the bottom. Hours, 24, 1. Anybody know how many seconds are in 1 hour? Okay, Finley bailed us out. Finley said 3,600 because he went, I think it's 60 times 60, 60 minutes, 60 seconds. If you know that, you can save yourself 1 step. So since Finley bailed us out, we can go straight from hours on the bottom to seconds on the top, and apparently 3,600 seconds is 1 hour. What am I going to do with that 7 and that 24 and that 3,600? I'm going to multiply, and the conversion factor answers that question for me. Because the big question Riley kids always ask is, Mr. Do I times or do I divide? I can't remember. I don't remember either. I let the conversion factor tell me. Hey, on your calculator, 7 times 24 times 3,600, how many seconds are there in 1 week? 604, 800. And units, because I don't want to work for Verizon. $0.002, 0.002 cents. Number 7, how many hours in 1 year? If you're a fan of the musical Rent, I think there's a song in Rent which might give you a conversion factor, because the chorus actually tells you how many minutes or hours or something. So you can have a shortcut, but most people don't have that memorized. I'm going to start out by doing what, do you think? Writing down what they gave me. What is it? 1 year. By the way, the proper abbrev for year is a lowercase a for annually. We can't use a Y because that's yards because of the Americans. If you use a Y for year, I won't take marks off. I'll give you full credit. But I'm enough of a nerd, Kalish, that I have to use the right abbreviation because, you know, me. All right. What can I break years into? Why would months not be the way to go? Because where would you go after months? Weeks? Is there exactly 4 weeks in every month? Days? Is there exactly 30 days in every month? I would not use months. You'd introduce error. Yeah. I would go to days. I would say 365 days is 1 year. Because I'm pretty sure all of you memorized that. I would not use weeks either. Some people, how about 52 weeks? It's not exactly 52 weeks. But the year is defined as 365 days, even though it's not that either, right? It's a bit off. Okay, I'm in days. What can I go from days into? Oh, hours. And I'm good, because that's what they wanted. So, I guess days on the bottom, hours on top, 24 hours, 1 day. I guess it's going to end up being 365 times 24. Which is what? Again, a good way to follow along, try these on your calculator. It keeps you involved and you get practice on your calculator. Is it 8,000 something? 8,760. And that is hours. Okay. How many seconds in 1 year? Oh. I'm going to start out by writing down what they gave me. 1 year. What can I convert years into? Yeah. What can I convert years into if I'm paying attention and happen to notice certain questions that I've just finished doing if I want to save myself redoing something and from scratch? What else might I be able to convert years into? Oh, pray tell. Hours? Don't be scared to look at previous work and say, oh, I've got a conversion factor on my page that I didn't know that I had. I have that sitting there. Why don't I use it? So I'm going to go from years straight to hours. 8,760. Yeah. Finley, how many seconds in 1 hour? Look at that. 2 lines and we're good to go. And I didn't have to pull out a whole bunch of, didn't have to memorize a whole bunch. And I don't need to guess, am I multiplying or am I dividing? Joanna, the numbers tell me everything. It's going to be 8,000. I'm curious about this one. It's going to be 8,760 times 3,600. 31536 and 3 zeros. 31536 and 3 zeros. And that's seconds. Looks like about 31.5 million seconds, roughly, every year.
You said 3 million, I told that.
Yep. 31.5 million seconds per year. So, don't waste them. So here's Mr. Dewick's unit conversion method. It works great. I always start out by writing down what they gave me. I write it as a clear 2-level fraction so I can tell what's on the top and what's on the bottom, unless there's an invisible 1 there. I look at the units and I find a conversion factor with those units. If the original units are on the top, they're going to be in the bottom of the conversion factor. If the original units are on the bottom, they're going to be on the top of the conversion factor to cancel out. As you go along, cross out the units so that you can see which units are left behind. And if you've done it right, then you've got a built-in error check, Ella. It should tell you whether you've done it right or not. Ooh, if we have a table of conversion factors, we're going to finish with example 9. I'm going to press pause. I'm going to give you the homework if you want to get a head start on it. I haven't really quite finished the lesson, but the first few questions you'll probably be able to do. But tomorrow I'll finish the lesson, and then it's going to be primarily a work period going into Flex, so you'll have a chance to get completely caught up. All right. Ruby, can you read to me number 9? How many what? Centimeters in 1 mile. I'm going to write down what they gave me. 1. Why can't I use an M as my abbrev for mile? Meters. The abbrev for mile is MI. Which means I can't use MI as my abbrev for minutes. The abbrev for minutes is MIN. Ruby, look at the chart. What can I convert miles into? Oh, so you're telling me if I put miles on the bottom, feet on the top, and oh, what a dumb system the Americans have. 5,820. And they got to memorize all these conversion factors. Our metric system, it's nice. It's all powers of 10. All right. If I stopped there, that would be feet. We want to end up in centimeters, Ruby. What can I change feet into? Inches? Oh. Okay. So feet on the bottom, inches on top, 12 inches, 1 foot. And Ruby, what can I change inches into? Oh, and now I'm home free. So apparently I can go inches on the bottom, centimeters on top, and 1 inch is 2.54. My units all canceled. Hey, I got centimeters, which is what I wanted. Anything on the top, I multiply. Anything on the bottom, I divide. 5,820 times 12 times 2.54. I got 177. Did I miss something? No, I think I've got feet, good. Inches, good. Is it 17793.6?
Yeah.
I missed a digit. 177,393.6. And that's going to be centimeters. Okay. Tomorrow, in number 10, do you notice now we have units on top and on the bottom, miles per hour? I like that question. I like that question. I like that question. So we're going to pause here. Bear with me.